Unlock your potential today at skillbakery.com.
Sometimes you need to display values in specific ways throughout your application based on the state that you are managing. The way to do this is to derive your state so you don't have to track multiple stateful items. In Jotai, this is accomplished by creating an atom, getting the value from another atom that you are managing, in this case from XState, and using that value how you need it in your derived atom. This atom will be re-evaluated every time the managed state changes. This pattern is great to use if you have complex state managed in something like XState, but need a derived state value that is not strongly tied to that managed state. The pattern works the same for async and synchronous function calls, as well as pulling in multiple atoms and libraries to use in your derived state. If I take you to the code now, the traffic machine is created with the createMachine function from the XState library. Now, over here, the traffic atom is created with atomWithMachine function from the Jotai XState integration library. So far, we have just used the machine wrapped in the atom. This can actually be done with the React integration library from XState. The benefit of Jotai XState integration is that we can derive machine atoms. Such derived atoms can be asynchronous or synchronous. Here we'll be looking at synchronous ones. So let's go ahead and define a function called fetchTrafficMessage, which will accept a parameter called light. Now this is the traffic light that we are passing over here, and it's just going to print that message. Return hello, and the value of the light will be presented over here. Here we have named this as async message atom, as we will be covering the asynchronous part as well. So here we have another function, async message atom, and it's using the atom from Jotai. As you can see over here, we have imported atom as well. Now this is basically getting the current value of the traffic atom, and it's assigning that value to this light, and this value is then passed to our method over here, fetchTrafficMessage, and that message is then returned. So whatever fetchTrafficMessage is returning, we are returning from this function. Now here we have our component called TrafficMessage, and we are using useAtom to make use of asynchronous message atom over here. And then we have the message here, which is being returned by the asynchronous message atom method. And we are returning it as an SVG component. If you notice, this is the same text value that we were earlier using, but now we are using it from a different component altogether. So here we are just printing this message that is being returned by asynchronous message atom, and that is what we are rendering over here. Now if I save this one and run it in browser, you'll notice that initially it's printing hello green. So the initial value of the traffic light was set to green. If I click now, you'll notice it says hello yellow and then hello red. So on every click, we are calling these state update from a different component altogether. Now, if I have to make this asynchronous, all I need to do is wrap my traffic message component inside suspense, and here the asynchronous message atom is now made asynchronous. So we have introduced async over here and await over here. Similarly, we have implemented asynchronous keyword over here, and we have now added a timeout which will mimic an asynchronous process. So now if I run this one, here you'll notice initially we have hello green. If I click now, it will take some time and then it will say hello yellow. Then again, it is going to take some time and it will return hello red. And this time interval that you see is actually mentioned over here as 1.5 seconds. This pattern is basically useful if you have a complex state managed by XState and derived state that are not strongly tied to the base complex state. The derived state can also depend on other atoms or even atoms from other libraries. If you find the video helpful, don't forget to like and subscribe.